Thank you for joining me as we explore wonders of the universe. In this episode, we look at icy wanderers. The solar system is surrounded by a swarm of tiny icy bodies, known as comets. They contain clues about the earliest formation of the solar system. Most comets roam the Oort cloud, named after the Dutch astronomer Jan Hendrik Oort, who predicted its existence half a century ago. This is a vast spherical zone beyond the orbit of Pluto and extending a third of the distance to the next nearest star. Comets interacting with the solar system at regular intervals drift in a disc-shaped realm beyond the orbit of Neptune, but closer to us than the Oort cloud, known as the Kuiper belt. When dust grains from a comet's tail collide with the Earth's upper atmosphere, they burn for a few seconds and then are gone. Meteor showers are as insubstantial as sprites. A well-known display, the Perseid shower, peaks in intensity around mid-August. A comet sweeping across the Earth's orbit in 1862 left slight traces in its wake. Eventually, these will dissipate. Comets may be the frozen remains of countless small-scale accretion events. They are light and insubstantial, with almost no gravity. Comets are probably the smallest accretion events that can occur. If we could capture one, we might see the tiniest seeds from which a star or planet might have formed. Some comets have been observed at close range by robot space probes. The main constituents are water ice, frozen carbon dioxide, and silicate dust grains. But many also contain simple organic molecules, such as ammonia, formaldehyde, and other hydrocarbons. Comets falling onto the young Earth probably contributed some of the building blocks for life. Pluto and its largest moon, Charon, appear as smudges of light in this Hubble Space Telescope image. So far, the best view that we have obtained. In 2005, Hubble found an additional pair of small moons named Nix and Hydra. They are visible as small specks at the right of the image. These tiny moons are 5,000 times fainter than Pluto. Discovered in 2003 in an orbit far more distant from the Sun than Pluto's, Eris caused a stir among astronomers, throwing into question what we mean by the word planet. When it became apparent that Eris is larger than Pluto, the International Astronomical Union reclassified Pluto as a dwarf planet. Another observation by Hubble resolves Pluto and the Charon in greater detail. The image was taken by the European Space Agency's Faint Object Camera in February 1994, when Pluto was 4.4 billion kilometres, or 2.6 billion miles from Earth, or nearly 30 times the separation between the Earth and the Sun. Forgive me for this pronunciation. Quaoar, spelt Q-U-A-O-A-R, orbits the Sun at a distance of approximately 6 billion kilometres in a region known as the Kuiper belt. With a diameter of 1,300 kilometres, 800 miles, Quaoar is significantly larger than Ceres, the largest asteroid. Intensive computer analysis of extremely faint and tiny images has revealed approximate details on the surface of Pluto. This scientific challenge is the equivalent of reading the manufacturer's name printed on a golf ball 50 kilometers or 30 miles away. Hubble observed almost the entire surface of Pluto as it rotated through its 6.4-day period. Pluto appears to have a greater large-scale contrasts than any planet except Earth. Most of the features are probably produced by frosts migrating across the surface, and chemical byproducts deposited out of Pluto's nitrogen-methane atmosphere. Sedna, the most distant object so far identified in the solar system, takes 10,500 years to orbit the Sun. It currently lies about 3 times as far from the Sun as Neptune, but its orbit will eventually take it 30 times further away. Almost nothing is known about Sedna, except that its surface is almost as red as Mars. This comet was discovered by NASA's Near-Earth Asteroid Tracking (NEAT) project in 2001, 3 years before it passed between the Earth and the Sun, at which point it was easily observed. Almost everyone has heard of Halley's Comet. It passes through the inner solar system once every 76 years and was first recorded in the year 240 BC. This close view of its nucleus was taken by the Giotto probe in March 1986. Proximity to the Sun causes volatile compounds, substances with low boiling points such as water, carbon monoxide, carbon dioxide and other ices, to evaporate from the surface, creating the characteristic glowing tail, which always points away from the Sun. Another view shows dark surface features on the nucleus, with gas and dust flowing into the tail, or coma, at left. The debris left behind Halley is responsible for the Orionoids meteor shower in October of every year, and the Eta Aquarius meteor shower every May. And here we have another comet I will struggle to pronounce. Discovered in 1930, comet Schwarzmann-Wachmann 3 orbits the Sun once every 5.4 years, coming to within 776 million kilometers, 482 million miles at its closest approach. It began to break up in 1995, splitting into 4 fragments. By 2006, it had disintegrated into more than a dozen pieces. It may not survive its next swing past the Sun. This infrared image from NASA's Spitzer Space Telescope shows Schwarzmann's Wachmann 3 skimming along a trail of its own debris. The flame-like objects are the comet's fragments and their tails, while the dusty debris trail is the line bridging the fragments. Debris ranges in size from pebbles to large boulders. Photographed in 2007, Comet Lullin's green colours comes from the gases that make up its Jupiter-sized atmosphere. Jets spewing from nucleus contain cyanide, a poisonous chemical found in many comets. In late 2006, comet McNaught became visible to the naked eye. It was the brightest comet seen in the last 40 years, but it is currently heading out of the solar system and will never return. The Stardust probe flew past comet Wild 2 in January 2004. A brief exposure of surface detail was overlaid with a long exposure of the much fainter jets. Together, the images show an intensely active comet leaving a trail millions of kilometers long. Discovered in 1862, Comet Holmes made a good display in 2007, when a rapid outburst transformed it from a faint comet quietly orbiting the Sun with a period of about 7 years to a naked eye comet rivaling the brightest stars. Approaching comet Tempel 1 at 10 kilometers or 6 miles per second, the Deep Impact Probe observes a primordial chunk of solar system material. Tempel 1's ingredients include tiny grains of silicates, iron compounds, hydrocarbons, and clays that must have formed in association with water. Here we see the view from Deep Impact Space Probe 90 seconds before it deliberately crashed into Tempel 1. The bright flash signifies the sudden release of energy triggered by Deep Impact's high-speed collision with the comet. NASA probe Deep Space 1 approached comet Borrelly in December 2001. The comet's nucleus is about 8 kilometers or 5 miles long and has smooth rolling plains and materials of vastly different reflections. Images taken at different wavelengths show dust jets escaping Borrelly's nucleus. Seen through Earth-based telescopes in 2010, Comet Hartley 2 is little more than a hazy speck of light. Closer inspection by the Epoxy mission spacecraft in November of that year showed jets of dust and gas indicating its active surface. In this image, sunlight illuminates the nucleus from the right. Hartley 2's jets in even greater detail. What appear to be loose boulders are visible on the nucleus. Probably the second most popular comet we have here now. Comet Shoemaker-Levy 9 was first detected in March 1993. Astronomers watched as it was gradually torn to pieces by Jupiter's strong gravity. In July 1994, a series of fragments slammed into Jupiter, leaving scars in the planet's turbulent atmosphere that took several weeks to dissipate. At least 21 impacts occurred on the far side of Jupiter, but as the planet turned that face towards the Earth, the impact zones were monitored in infrared, highlighting the immense bursts of energy of the collisions. Visible meteors are typically sand-sized grains of ice and rock fragmented from comets. Distributions of flashes in the night sky are mapped, showing particular concentrations associated with known comet tail debris. These NASA Hubble Space Telescope pictures of comet Hale-Bopp show a remarkable pinwheel pattern and a chunk of free-flying debris near the nucleus. This may be a piece of crust that was ejected into space by the comet's rotation, and which then disintegrated into a bright cloud of particles. Comet Hyakutake, hope I've said that right, discovered in January 1996, passed very close to Earth in March of that year. It was moving so rapidly across the night sky that its movement could be detected against the stars in just a few minutes. NASA's Spitzer Space Telescope shows the comet Encke riding along its pebbly trail of debris between the orbits of Mars and Jupiter. Twin jets of material can also be seen shooting away from the comet in a fan-shaped emission. Encke orbits the Sun every 3.3 years. Every October, Earth passes through its wake, resulting in the well-known Taurid meteor showers.
And that ends our look at the closer items in our solar system. If you enjoyed this at all, do please hit the like button and please subscribe to the channel, and if you hit the notification bell you'll be alerted when our next video drops, which is on interstellar space. And believe me, the images there are absolutely outstanding. Thank you very much for watching. Do take care, stay safe, peace everybody.